welcome to Command Line Essentials.
Hello.
I'm Charles. Nice to meet you all. So why study the command line? Basically, it allows us to do things a lot more quickly. Even though that may seem a bit counterintuitive, as interfaces are good and all, but there's certain tasks where the command line is simply more efficient, and we'll learn about that. A main advantage of it, and the main reason why Unix/Linux has become what powers the servers of 96% of the internet, is because it allows programs to easily work with other programs, and that's called redirection. To drive that point home a bit more, I'm going to show a quick 1-minute video, and it'll be spoken by the guy who helped invent Unix, wrote B, the predecessor to the C programming language.
Back in 1969, a couple of computer scientists here at Bell Labs started to develop some programs they needed for their own use. What Ken Thompson and Dennis Ritchie started developing then has evolved into the Unix operating system, which by now is widely used around the world.
We were trying to make computing as simple as possible. In the late 1960s, Dennis Ritchie and I realized that the then current operating systems were much too complex. We attempted to reverse this trend by building a small, simple operating system on a mini computer.
Well, what we wanted to preserve was not just a good programming environment in which to do programming, but a system around which a community could form, fellowship. We knew from experience that the essence of communal computing, as supplied by remote access time-sharing systems, is not just to type programs into a terminal instead of a key punch, but to encourage close communication.
The Unix system started out as a two-man effort, and by now it's used all over Bell Labs. We have close to 20,000 computer terminals in this company, roughly one per employee, and most of them are used for communicating with Unix systems. One of the main reasons the Unix system is popular around here is because it provides graceful facilities for decomposing complex computing tasks into simple subtasks.
The Unix operating system is basically made up of three parts. The kernel, or operating system proper, is the part that manages the control of the machine and supervises scheduling of the various user programs. The shell, which is the name we give to the command interpreter, looks after the communication between the user and the system itself. And the third part, which is actually the largest, is the various utility programs, which perform specific tasks like editing a file, or sorting a bunch of numbers, or making a plot. In other words, all the other programs that are not provided directly as part of the operating system kernel.
Oh yeah, and the other thing is it makes you look cool when you open it up in a coffee shop. Command line utilities are usually a lot lighter, and you'll see here that VS Code is 113 megabytes, while Vim is less than 2.5. It's not so much about the storage on the computer, it's about the amount of RAM it takes up when it's running. Oh man, it's hard to see the code. Let me see if I can get the projector to be a bit clearer. So when you want to print something to standard output, which we'll talk about later, you use the echo command. It's called echo because it used to be, back when that video was first made, that getting things to print to the screen was a lot more of a hassle than it is now. And echo is, what you put in is what you get out. After that, you'll see the CD with the tilde. That changes what your current working directory is. That's where you are on the system. The tilde represents the home directory. And some things will be within the home directory, but you'll see that other things aren't. And then ls will print all the files that are in your current directory except for hidden files. And to create a directory, mkdir, make directory, creates one.
Curious question, what's the equivalent for that for Windows computers?
Oh, I probably should mention. Since 96% of the internet is running Linux, I will be focusing on that. For the activity that we have on the end, I'll have you open an online playground, so it will work irrespective of your system. So it'll all be done in the browser.
Can I make a quick comment about Windows?
Yeah, sure.
So if you're on a Windows system, you can install a Windows subsystem for Linux, which allows you to actually run a Linux shell on Windows. So you could use all the following commands and not necessarily worry about what the same commands are on the Windows system.
Yeah, that's a great point. Microsoft has been embracing Linux in recent years, and a lot of Azure is actually running Linux, ironically. File permissions. So when we want to create a file, Touch will create an empty file. A thing to note about files in Linux is that they're all the same. Whatever, in the sense that it doesn't matter what extension you give it, it's just blocks of data on your disk. That next part is we're adding a line to a shell script. We'll talk about the redirection that's used later. And then we list it out. It's hard to see because it's green, but basically there's 9 digits, or 9 characters, I should say, and because it shows that part because we gave it the -l argument, but files have 9 bits that represent what the user and other people are allowed to do. The first 3 are for the owner, the second set of 3 is for the user group, and then the last set is for everyone else. The way it is on that line is it currently doesn't have, each of those characters are for read, write, and execute. And at the moment, we haven't yet given the shell script permission to execute. So when we try to run it, which we do with the /script.sh, it says permission denied. So we use the chmod command, change mode is what it's short for, and then give it a 7, which is sufficient for it to execute, and then the 5 5s say that everyone else can read and write to it. So when we run it on that last line, it prints out hello world, because that's what we gave it. That's what we appended to it in the first one. Any questions so far?
What is the number system for chmod code? Is there a name for it? Because normally you do like the D plus syntax, you know?
They're interchangeable. So if you wanted to do 755, that would be a plus X.
Yeah. But is there a name for that kind? I'm just curious to like where I can look up the number system.
I don't know what you call that, other than that you're just changing the bits of the file permissions.
Okay,
There's, I'm sure there's a word for it, but
Yeah, that's alright. That would be Thank you.
So certain tasks you'll be doing, you'll need super user permissions. But there's also other tasks where if what you're doing isn't designed to be run in root, like some installation scripts, sudo will actually make it not work. Sudo is for super user do. And you're basically saying that you want to run the command as root. And to do that, you don't need to log out and log back in. It's very convenient in that. Chmod, as we said, it changes the file permissions. when you assign a file or a directory to a group, any user who is a member of that group can access the resource. Counterintuitively, read access to a directory only lets you see the file names and traverse it. You can't recursively see the data of those files. Execute permissions on a directory allow you to enter and traverse it. I talked about the /bin folder. That's where the binaries of the actual applications of your system are. So every time you run ls, like I said, or make dir, those are all files that exist in the /bin directory. Even bash itself is a file in the bin directory. So files on Linux, they all have inodes, which have all the metadata except for the name. And this lets us do things like links. What links do, let's say you have a very large machine learning on your computer, and you want to access it, you want it to have it be accessible in 2 different places on your system. It would take twice as much memory if you had to copy that same file to elsewhere on your system. So for that we have links. There's 2 types. The default is hard links, and they directly point to the inode of the file, not the file name. They're a bit more durable in that they don't have dangling references, because the other, symbolic references, it's just a shortcut to a path. So if that file gets deleted, the links aren't updated. So you could potentially have links that lead nowhere. To create links, you use the ln command, and if you want to make them symbolic, do a -s. If it's a directory, you could only use symbolic links. Oh. Yes?
There are 2 links to a file, and say both programs are using a symbolic link, can they use that one file simultaneously, or will it be conflicts?
Only if that program has a lock on it. I unfortunately don't go into locks in this lecture. Sorry.
I think if you do open it in 2 different shells or 2 different programs, when you close it, especially if you have like 2 terminals open, and you open the same file in 2 different terminals, 2 different shells, when you close it, if you made changes, it will let you know. I think, if I remember correctly, it's like issues a swap file, and it recorded the difference between the shell you're in and the other shell. So I don't think you can, but it will warn you if you try to.
But there are situations where you'll run a program and it says, oh, we tried to access this file, but a different process has blocked. So text editors. Now, I imagine a lot of you love the features of an IDE, and they're good. But it's good to have experience with at least one command line text editor. The reason for that is because if you SSH into a server, that is a secure shell where you're controlling that server, you're often not going to have a full-fledged VS Code just sitting there. And you also probably won't have a GUI that you'll be able to access. VS Code will let you you can edit files from VS Code remotely, but in my experience, it's often very slow. But if you spin up any old Linux instance, by default, it will have V, which is like the original version of Vim, and you'll be able to edit files. Like, let's say you want to make a quick change to configuration file, or like you could just quickly use that without installing any additional software. The one thing about Vim is you may hear jokes that it's hard to exit. If you want to exit, there's a couple of ways, but you essentially need to hit colon first and then Q. I won't go into all the shortcuts, but a quick look at a Vim cheat sheet might be helpful. There's also Emacs. It's very extensible, and you can customize it with Lisp. Lisp is a really old language that's still in use today. Nano is a bit less common, but it's simple to pick up. And since we're mentioning Vim, I put my cat up there because my cat is named Vim. Just thought I'd include that.
So you don't use Emacs, right?
Know that meme? Like how you exit Vim?
What?
Know that meme? It's like how you exit out of Vim?
Yeah. There's a couple of ways to do it, and it depends on whether you want to save the file. So auth, it's short for the last names of the guys who invented it, and the K is Brian Birmingham, who was the guy from the video. But basically, it's a very powerful way to see whether it processes a condition if one is provided and then takes an action to print. So the example we have here, this one, it's printing the 3rd and 6th row, and then of that, it iterates and prints the 1st row. NR, in this case, it's kind of cut off. That line on the lower left bottom is what I'm talking about. But NR usually will be the line number, but if you're using a different delimiter, it could be something else. We also have sed, which has less features, but it's very good when you're having programs that talk to other programs. Like, it's good for one-liners and pipelines, which we'll talk about later. Linux has 3 channels. I don't list it here, but there's standard input, standard output, and standard error. This is one of the main benefits that made Unix so popular, and eventually Linux, is because the fact that these are standardized makes it easy to combine programs. Before this, if you wanted to have one program talk to another, you would have to hope that the developers made it easy to do that. This way it allows programmers to use programs in ways that the original authors didn't even foresee or intend. So the first echo, this is just printing a standard out. Then the next one is it's piping it to standard error. And then next, where we can save it to a file. That's what the right bracket to standardout.txt is. And then the last one, what it's doing, the last one is first taking the echo's output, it's piping it to standard error, and then it's taking that and piping it again to standard error.txt. It should be noted that if you want to redirect the same input to multiple places, you can natively do that. To do that, you need to use a command called tee, and that will allow you to do that. The reason why it doesn't let you do that natively is because the big benefit of doing things this way is that you can Like, let's say you have a server that generates a lot of, you're using someone else's program and it generates a lot of output, but doing so is an expensive operation. So you want to have that go nowhere so that your program will go faster. What you would do is you would pipe it to dev null. Dev null is basically it's like a virtual device on the system that just sends it to nowhere, deletes it. The dev folder in general represents things like the keyboard. The keyboard is actually a file in the Linux system. It's because everything is standardized. So like there's a virtual file that represents the keyboard and so on. So for finding files, we have two ways. The first one is called find, and that's very good for finding the file themselves. But grep, which is short for global regular expression in print, it looks within the file. So if you want to find something within a file, use grep. But if you want to find the file itself, use find in general.
And when you say find the file itself, you just mean find is only searching, whatever you pass the find is only searching based on the name of the file, right?
I think always. I'm not sure whether you might be able to do it otherwise,
And
but
find searches for directories too.
yes.
It's an option. You can see up there the dash right F is searching for files. If you did the
Okay, got it.
So this example we have here, first it's looking for all the JPEGs. That asterisk is in a wildcard, so it's looking for any file that that ends in .jpeg. And then it allows you to run a command for each of those. So we're using changemod to change the permission. The brackets are a placeholder, and then the / colon is optional, but it would be good here to add just in case you're using this in a script or something. Sorry.
What does the backslash colon do?
You don't actually need it. Sorry. You don't actually need it here, but it's just colon is kind of similar to how you would in program. Like it ends the statement.
Oh, you have the backslash out. Okay.
You don't have to here. I just added it here to make an example.
Okay.
But yeah. This first grep, it's just looking inside files and it's taking the search term and it doesn't care what case it is. The next one is counting the number of occurrences with -c, and then -n is, it just lets you see the whole line where the matches occur. So like let's say you're looking for bugs, you may want to see the whole line of where the bug occurred. So pipelines with the bar character allow you to send the output of one command to the input of another. Standard out, when you're redirecting standard output, it will, if the file doesn't exist, it will make it. If it does exist, it will overwrite it, so you may want to be careful when using that. Standard input redirection is basically the opposite. It's just sending it in another direction. If you want to append to a file, like we did earlier, you'll use two right brackets. And if you want to send the standard error instead of standard output, you'll put a 2 in front. So this first command is grepping for the word error in a log file, and then it's using a program WC, which counts the number of words. We're giving it -L so it knows to look at lines instead of just words, and then it's sending that to a text file. Here we're just listing all the files of a directory and sending it to we're appending it to the end of a file. And then this next one is we're using the find, and since we're sending standard error, this would send things like, let's say you don't have permission to look at a directory or file. It'll send an error. So only those errors will get sent to error.txt instead of all the successful finds it had. This last one, it's printing it to standard out, but then it's converting it to standard error with that bracket &2. And then lastly, we're sending all standard error to standard error.txt.
Quick question about that first line, the correcting the error in the log file. Does the correct part of the statement before the pipe, does that output the words of occurrences, and then the word count counts how many words, and then that's what ends up in the count file? Because you're piping you have like two commands there, right?
Yeah.
What's the output of the command on the left side of the delimiter?
The grep it'll print the whole line where it finds the word error.
Okay, and it'll print every line that has a word error?
Yes.
Okay, and then that gets piped into word count. And that's where it counts however many times. So you could expect in the count file to see like a number. Is that correct?
Yes.
Okay. I find that understanding just for anyone else who's wondering.
No, yeah, that's very good
I find like understanding the anatomy of a command in the command line or on command line is like super, super helpful. Once I realized that like I was just writing a series of commands, typing one output to the next command to the next, and then putting it into a file, things clicked for me. So that's why I was just clarifying, like, there was an output on the first side, and then you use that output in the second side to then result in a file. For anyone else who was thinking of that.
Yeah, I'm glad you asked that. So, believe it or not, you don't want to hard code sensitive information for your programs like the database key directly in your code. So there's a number of ways you can not hard code them. There's things like AWS Secrets Manager, which will do it for you, but the tried and true way of doing things is to have them stored not as a variable in your code, but in the environment. So you're basically setting variables in Linux. And it also allows for portability of programs. So let's say you have a script that compiles Java, and you don't know where the user's Java home is. Like if you have a Java environment set up on your computer, you'll have somewhere you will have specified where your Java development kit is. So if you make a script that you want anyone who has Java to run, you would have it rely on the Java home environment variable. And of course, for security, it lets you not hardcode things. So this first line, we have an export. This only does it temporarily. So once you close out of your terminal, my var will no longer be there. But here we're using the echo command to do that same command and then append it to the bash rc file. What the bash rc file is it's a configuration file for your bash shell. But if you're using something like ZSH, you'll instead use ZSHRC. This file gets run every time you start up your terminal, so you can expect myvar to be set whenever you open up your terminal. But once you do that, unless if you close and enter you don't have it yet until it's run. So if you want to have it in the same session to save you some time, you would use the source command to, well, this is a typo, but that should say .bash rc to run that same file. Now, if we echo it, we'll see that it's there. And then another way, you could also set environment variables for the lifetime of the command. And to do that, you put it directly in front of the command. Environment variables will be in all caps.
When you do the append, does it always do a new line? When you do the double caret for the
I believe it does.
new line?
Yeah, it'll put it on a new line.
Okay.
The single one will just replace everything in the file.
Yeah, that I got. Okay.
So we won't always want to be doing all this stuff manually. So for that, we have shell scripts. Variables are local to the script, so if you set an environment variable in that script, you won't have it once you read the script. It can save you a lot of time by using them. And since shell scripting is a lot less verbose than most programming languages, you can often write them pretty quickly. I know oftentimes the shells, I will do the commands manually first, see that they work, and then add them to a shell script. They're also a good way for cross-platform support, so you'll see a lot of programs on GitHub will have, instead of a typical installer, they'll just say in the instructions, run this shell script, and then you'll have the program set up on your computer. At the top of every shell script, it's technically optional, but I'll tell you why in a minute, why it's good, is you'll have this, this pound sign exclamation point is called the shebang for some reason. And then we're specifying that we're using bash. So it's telling us where bash is located. It's a binary, so it's in the binary folder. But in theory, you could have some other shell that's stored elsewhere on your computer, and this is where you would say it. I can't think up of any particular examples, but when Linux is looking at files, it quickly looks at the first two digits, and if it first two characters, and if it sees this, it will know that it's an executable and will treat it as such. We're defining some variables. Since what this script is doing is it's backing up files, we're saying the source directory where it is, and then we make backups, and we don't want to have to specify the date each time. So putting it in the shell script, we just use the date command, which is available on Linux, and then specifying how we want it to show up. And the $sign parentheses is what's actually like appending it to the backup path. So then we make a directory. I think the -p is for if the directory doesn't exist already, it won't throw an error. And then we're copying things over. The -a preserves all the attributes. And then at the end, we just print out a helpful message saying that it's done. This is a bit more complicated than redirection, but if we want to use the output of one command as the command line arguments, not the standard input, but as the command line argument, arguments to another command, we'll use xargs. It has some benefits in that it's less expensive than loops because it doesn't spawn new processes. So this command, we're using the find command to find all files that end in .log, and then the print 0 specifies that anytime we see as a new null character, it's a delimiter. It's like, it means we're looking at a new element. And then xargs, we're telling it to expect that. And then using the tar command, which compresses files, to compress them with several, I won't go into what this is, but it's compressing them into archive.tar.gz. Some more helpful commands. It's not expected that you're going to memorize all the command line arguments for all the commands in Linux. So man, short for manual, will quickly give you a rundown of how a particular command works. Touch will create a new file. It'll be empty. If it already exists, it will update the timestamp of when it's last modified. CP is for copying things. If you want to copy everything within a directory, you'll need to tell it -R for recursion. And it doesn't modify the original file. It completely copies it over to a new place. Next we have MV, which ironically doesn't always actually move the file. Obviously, if you're moving something from your computer to a flash drive, it has to do that. It has to physically move the file. But oftentimes, if you're just moving a file, like one directory for up, all it's really doing is just updating the file pointers. The actual blocks of storage on disk don't actually get moved when you do that. So here's an example deployment script that we'll walk through. First, we say where the code is. We're saying where it's going to be stored. We're saying what the user is, and then we're defining which web server we're going to use. This one's Nginx, but someone can change it to Apache and so on. Then we do sudo apt-get. What it's saying is to apt-get update. It's saying to fetch from the repositories all the programs that are available for download with the apt command. And then we're saying to update them. The -y says that the answer is yes to any questions it may have. So the reason we do that is because the shell script would stop until the user provides the Y key to user input, and we don't want that in a shell script. We want it to run automatically. Next, we're saying install git, say yes if it asks. Then we're saying install the web server that we specified earlier and say yes. Shell scripts can have if-else statements. The syntax is a bit weird. We have because we're saying if, then, and then else, and then fi means we're closing the else block. What's happening here is this is running a command called test, and it's testing whether that directory exists. We're doing git-c pull. I'm forgetting what the -c actually does. But in the else block, we're cloning the repo, and then we're setting the permissions. since this is a node application, we'll be running npm install to install the dependencies of the project. And then we're gonna, systemctl is for services. Here we're restarting the web server to accept our new changes. Okay, boring part's over. Now we'll be doing an activity.